Hey everybody, we're going to take a look at putting a lot of ideas together that we've studied so far. And so if we take a look at this chemical formula, and we know that when a lot of the units are left off here, which says 2H2, but we want to remember that's 2 moles of H2, and 1 mole of oxygen will make 2 moles of water. Okay. Now when chemists actually go to do their experiments, they want to be able to figure out, well, how do I do this? How many grams of chemical do I weigh out? So, here's how we'd figure it out. So if 2 moles of hydrogen, we want to know how many grams that is. So I'm going to set up my proportion. Okay, so how many grams is in 2 moles of hydrogen? Okay, I'm going to put grams on top and moles on the bottom. And the molar mass of hydrogen is 2 grams for every 1 mole. Okay, so in H2, you have 2 H's. You look on your periodic table, and we see that you're going to take 2 times our molar mass of hydrogen, which is 1, that equals 2 grams. Okay. All right. So, similar here, how many grams are equal to 1 mole of oxygen? And so, moles here, gram. Your molar mass of 2 oxygens is going to be 2 times 16 grams. That's going to be 32 grams. Okay? So, if you're on your A game, you would realize that, well, 1 mole of anything is just the molar mass, so you could just look it up. So our answer is going to be 32 then. Okay? Our answer for the first one would be 2 times 2 divided by 1 is going to be 4 grams. Okay. And then similarly down here, how many grams are going to be in 2 moles of H2O? And so, let's see, we put moles on the bottom, grams on top. Molar mass of water is going to be 18 grams. And so you got 2 H's plus an oxygen, so it's going to be 2 times 1 gram, okay, plus the 16 grams from oxygen. That's how we get the 18 grams. So 2 times 18 is going to be 36, okay. We're going to take these numbers and add them up to our equation. That's why we're doing that. So this is 4 grams. This is for hydrogen, so I'm going to put 4 grams here. The 32 grams is going to be from oxygen, so 32 grams here. And then this 36, okay, is going to go here. But you'll notice by doing this, we do recognize the law of conservation of matter holds. You get 4 grams plus 32 is going to equal 36, so that everything sort of makes sense. Okay, so if I wanted to make this reaction and do this reaction as is, I would need 4 grams of hydrogen, 32 grams of oxygen, and I would make 36 grams of water. Now we know that sometimes we don't want to do a recipe as we have it written, so what we're going to do is we're going to use this information, these proportions here, to be able to solve some more problems. Okay, so skipping down here, so number 4 says how many grams of hydrogen, so X grams of hydrogen, are needed to react completely with 65 grams of O2. Okay, so I'm going to put grams of hydrogen on top and grams of oxygen on the bottom. And the only place that 2 different chemicals are ever compared is the equation. So I'm going to go up to my equation and find out how many grams of hydrogen I needed. Okay, and that answer was 4. So, and then for oxygen it was 32. So I'm going to put 4 grams here from my equation and 32 grams there. So to get my answer, I'm going to multiply 65 times 4. And then divided by 32. And I get about maybe 8.1. My units are grams of H2. Okay, so we're going to be using our equation for all of our information here. Okay, number 5. Number 5 says how many grams of O2, so X grams of O2, are needed to make 100 grams of H2O. You can kind of ignore this thing right now. We'll come back to it later on. are needed to make 100 grams of H2O. Okay. So you bring your units across, grams of O2, grams H2O. Our grams of O2 are the same as we had before, right? Because this side, the right-hand side, is going to come from the equation. So 32 grams. And let's go up to our equation. How many grams of water would be made from just the equation? And that answer would be 36. Okay. So we're going to put 36 grams down here. So I'm going to take 100 times 32 divided by 36. All right, and so I should get about 88.9, something like that, grams of O2, depending on my rounding. Okay, so we start to see sort of the pattern. We're going to use all our information from the problem, and so let's just kind of round things out. Using the equation, how many moles of H2? How many moles of H2 are needed to make 75 grams of H2O? Okay. So I'm going to put moles H2 on top. I'm going to put grams H2O on the bottom. I'm going to go to my equation and figure out how many moles of H2. Okay. So remember, now we're not using grams, we're using moles. So I've got 2 moles. All right. So that's the number I'm going to put on top, 2 moles. And the bottom is going to be 36 grams. Okay, so I've got 2 moles and 36 grams. Okay, so now I've got to do my math here. So 75 times 2. All right. And then divided by 36. So we get about 4.2 moles of H2 for our answer. Okay, so we're always using information from the equation. That information could be moles, could be grams. It's generally not going to be atoms, so we're going to be sticking to moles and grams just like that. Okay. One more problem to take a look at. So it says how many grams, so X grams of H2, all right, with an excess of O2 are needed to make 4.3 moles H2O. Okay. So I'm going to put grams H2 on top, and then moles H2O on the bottom. And so now I need to go up to my equation again. Maybe you remember it. So for grams of H2, okay, grams of H2 it was 4, and moles of water was 2. Okay, so I'm going to go 4 grams there and 2 moles. Again, everything here is coming from the equation. On the left is coming from the problem. Okay, so I'm going to take 4.3 times 4 divided by 2, and I get about 8.6, and then my units are grams H2. All right, hopefully that's helped. Practice makes really helped. Do some of these a little bit more complex problems. Thanks for watching.